Hello, student. Share force and bending moment for overhanging beam. Overhanging beams. First of all, you know that what is the overhanging beams. In previous class, we have know that draw the different type of SFD and BMD in the simple supported beam and the cantilever beams. And today we're going to discuss about the overhanging beam. How can draw the SFD and BMD in the overhanging beam? So let's start. How can I draw? How can I solve this SFD and BMD for the overhanging beams? So first of all, know that what is the overhanging beams? The overhanging beam is the beam if the 1, 2 end is fixed supported, but if like this, like if here you can see that if the one end is support here, one end and two or more than support here, so this portions is a hanging portion. That means the if it is a simple supported beam, is the extra portion is hanging of the beam, this it is known as the overhanging beams. So here today we're going to discuss about the overhanging beam. How can I draw the overhanging beams? Draw the SFD beam for the overhanging beams. Now let's see how can I draw the overhanging how can I draw the SFD and the BMD. So here we can see that it is a overhanging beam. Suppose this point is point A. Suppose this point is point A. This this point is point A. This point is point B. This point is point C, and this point is point D. D point, this is the point A, this is the point B, and this is the point C. Then how can I solve the SFD and BMD? First of all, find out the reactions at A, that means RA and the RB. Then here we can easily write here RA plus RB is equal to how much? RA RB is equal to 5 plus 6, that means 11. Then taking a moment about point A, then you can easily find out the RA and B. So take a moment and simple as like simple supported beams, taking a moment about point A. Take a moment about point A. So what is the moment about point A? So therefore RB into, so take a distance from this point. Suppose take a here here we can see that the distance is very important because so take a distance here to here, again here to here, and again here to here. So take a distance from this point to this point also, and also this point to this point. Here take a distance 2, here take a distance 2, here take a distance 2, also take a distance 2 meter, 2 meter, 2 meter, and 2 meter. So then take a moment about point B is equal to how much? Then take a distance about point B is equal to RB into 2 plus 2 plus 2 plus 2, that means 8, equal to 6 into 4, 6 into 4 minus of 5 into 2, 5 into 4. 24 minus of 10 is equal to 14. So RB is equal to 14 by 8 is equal to how much? 14 divided 8 is equal to easily calculated. That means 1.75. So this portion is 1.75. So RA plus RB is equal to how much? Then RB is equal to 1.75. Then RA is equal to how much? Then RA equal to RA is equal to, find out here, RA plus RB is equal to 11. Then RA is equal to 11 minus 1.75. So minus of this one, then we get the value of 9.25. So 9.25. So we can value the RA and RB. Then draw the shear force and bending moment diagram. So how can I draw the shear force and bending moment diagram? Let's see. First of all, you draw the loaded diagram. So how can I draw the loaded diagram? So these diagrams also need for the SFD and BMD. So I have erased some portions due to understanding. So take this figure here, here, Control C, and take from figure here. So first of all, the loaded view. So here can also 2 to 2. Then for SF, first of all, you draw the loaded beams. Then first of all, draw the shear force. So shear force for shear force shear force at here B. Suppose at B, C, D, and A, and shear force at B. B is equal to how much? Shear force at B is equal to, value of B is equal to 1.75 plus, because it is the upward direction because of positive force supported. Then similar shear force for at C plus 1.75, and similar method minus of, because runout force, what force? That is the 6. So minus 6. Then this one is equal to how much? This one is equal to 6 minus 1.75. 6 minus 1.75. 4.25. 4.25. 4.25. D is equal to what? Sorry, this one is minus because of 6 is greater than 1, that D is equal to how much? So D is equal to minus 4.75, and what is the value of D? D is 5, 5 minus 9.25. Then point A, point point A is equal to how much? You know that point is equal to 0 because of fixed point. About any fixed point, moment equal to 0. So similar way you can find the BM. For BM diagram, BM at point free end is equal to 0. BM at B. Let's see. B also 0. No force. Then BM at C is equal to how much? Then BMC is equal to this load into distance. That means 1.75 into 2 plus positive because of upward directions. So plus 1.75 into 2. That means how much? So 1.75 into 2, 3.5. Into meter. Sorry, SF not actually 0. SF this point is equal to, sorry, uh, SF this point is equal to not a 0. Is the value of how much? The value of 4 point. I already find out the SF at A is equal to 9.75. 9.25. So putting the value of here 9.25. Now, and SF at D is equal to how much? SF at D, sorry, BM at D. Then the upward force 1.75 plus into distance 2 to 4. You can see the figure here, here 2, here 2. It means 4. Then 2 to 4, then 6 Newton minus 2. Then minus of 6 into 2. That means 1.75 into 4, 1.75 into 4 minus of 12 minus 5. That means this one is equal to minus 5 kilonewton into meter. Then Bm at A is equal to how much? Bm as A is equal to, we already know that about the any fixed point Bm is equal to 0. So you can write A is equal to 0. After that, draw the SFD and BMD. So here see that how can I draw the SFD and BMD? First of all, you draw the loaded beam. Here, one end, I draw this one, sorry, or erase this one. Okay, this one. So one force is here, and another force is here. Is the A, B, C, and D. After that, draw the SFD and BMD. As you know that when you draw the SFD and BMD, you must draw the straight line every point. Draw here, draw here, draw here, and also draw here, and take your reference line. Taking one reference line. Now, how can I draw the SFD and BMD? SF at, so sorry, also you draw the reference line from this point, 3 end. So it is this line, and again draw the here. And free end SF equal to what is 0? No force between this, so also is 0. But here at B is equal to how much? The value of B is equal to positive. So we can take a positive here. So you can take a straight line from here to here. What is the value of this point? We already find out positive 1.75. Then at point C, what is the value at point C? At point C, minus 4.25. At point C is equal to minus 4 points minus. That means no load between this, so minus 4 point. Again draw here, straight line. So what is the value of this point? Minus of 7 point, minus of 4 point. Then at point D, no load between this and this. So sorry, some mistake here. So draw from here at point here. So line should be this line, not a straight line, this line. And again, draw the SFD from no force. What is the value of D? D is the 9 point. So D is minus of 9.25, and again A is 9.5. So this diagram is called the SFD diagram. This diagram and this diagram. This diagram is called the SFD. It's called the SF diagram. Then draw the BMD. So as we know that, what is the BM? How can I draw the BM diagram? If I draw the BM diagram, here let's see, draw a same reference line from point, this is point. this point, this point, this point, this point. So draw a straight line here. Then BM, no BM here, so BM is equal to 0. But here also 0 because of fixed point about any fixed point about BM is equal to 0. You see the diagram here. So BM here is equal to 0. Then BM at this point. So no load condition, the BM also 0. But this point is BM is equal to how much? Point C. I think point C is equal to, I've already find out the point C. So let's see 3.5, then minus 3.5. So here, to draw a direct straight line. For BM diagram, you can draw the straight line, but shear force. Then D is equal to how much? Minus 5. And again draw the straight line from here to here. Here, then how much value of BM at point C or D, and point again, this point is equal to 0. Also 0. Sorry, this one is also 0. So must be here, not here actually. Draw from straight line here to 0, here to here. Then again draw here to here, and again draw here to here. So BM, so this is the calculating diagram of the BM. So this way you can easily draw the SFD and BMD for the overhanging beam. I think you understand. So try to understand. Then next sessions we will also try many problem. Then you can easily understand the overhanging beam. It's more complicated than others too. So cantilever and the simple supported. So let's see what we will do in next class. And I think you understand better. So thank you, student, watching this video.